Thank you everyone. Today I am going to discuss about reflection of sound. Sound is a mechanical wave. It reflects from the surface like light. The wavelength of sound is about 1.75 centimeter to 175 meter, which is larger than the wavelength of the light. As the wavelength of sound is large, so it requires a large reflector. And these reflectors should or should not be highly polished. The big wall, buildings, hills, mountains, forest, dam, etc. act as the reflector of the sound. Like light, sound also obey the laws of reflection. First law, the incident sound wave, reflected sound wave and the normal at the point of incidence on the reflecting surface are coplanar. That means lie in the same plane, which are the incident wave, reflected wave and the normal are coplanar. Now the second law, the angle of incidence of the sound wave is equal to its angle of reflection. That means angle of incidence and angle of reflection are equal. These two laws like as the reflection of light. Now the application of reflection of sound. First one is the speaking tube. What is speaking tube? It is a cylindrical tube. When someone speak at the one end, then the voice, that means sound, gets reflected several times in the inner wall of the tube and reaches to the other end. Here the sound does not scatter. It remains concentrated within the limit of the tube. That means it does not goes out beyond the tube, and that is why the sound reaches to the other end of the tube with greater intensity. Now the another application, it is the stethoscope. We have the experience to go to the doctor's chamber. When we go to the doctor's chamber, then the doctor visits us with a stethoscope if it is needed. This stethoscope have two parts. One is the circular piece with the diaphragm and another is the two rubber tubes. Rubber tubes looks like that. When the circular piece is pressed against the chest of our body, then the beating sound of heart or lungs produce the vibration on its diaphragm. Due to the vibration of the diaphragm, the produced sound undergoes multiple reflection on the inner wall of the two tubes, that like that. This is the inner tube, inner wall, and the beating sound of diaphragm reflects in inner wall of the two tubes and ultimately reaches to the doctor's ear. This is the mechanism of the stethoscope. Now the other use. And it is a acoustically designed auditorium. Nowadays, the ceiling of the auditorium are suitably curved so as the concentrate sound by reflection at various points of the hall. That means sound from the curved ceiling of the auditorium gets reflected and reaches to the various points of the hall with suitable intensity. Now, another term is echo. Echo means is the repetition of sound, but this repetition of sound is caused for the reflection of the sound. So, echo is defined as an echo is the repetition of sound caused by reflection from some distant reflector. But we do not hear the echo in every sound because of to hear the echo there would be a certain minimum distance from the source of the sound to the listener. A clear echo can be heard if the reflector is more than a certain minimum distance from the source of the sound. If the listener stay below that certain minimum distance from the source, then echo cannot be heard. Now the question is, what is that certain minimum distance? This certain minimum distance can be calculated by a numerical calculation. This calculation will discuss in the next video. Thank you.